And we're back, Math 8 students, for our second lesson. So I'm going to go ahead and sit down and put on the projector and we'll be ready to go. All right, this is lesson 11.6. Now I know this is our last lesson before break, but I want you to know it is a very important lesson. If you have learned about slope before now, that's great. This will be a review and also will extend the idea. If you haven't, then I want you to be especially sure to take good notes on this because learning the slope of a line is very important. Now, when we talk about a slope in real life, usually you think of the slope on a hill or a mountain, like ski slopes, and that's because it's about the slant coming down a hill. The slope could be for beginners, intermediate, or advanced skiers. And the more advanced, of course, the steeper the slope. Well, we have a way that we use slope in math. And so if I had a picture like this, and I had a picture like this, you can see with my two hills there, that I have a slope here, and I have a slope here. And this slope is flatter than this one. Or you could say the second slope is steeper than the first. And we use slopes when we are talking about the steepness of a line, usually. So we're going to have a definition for slope. In math, it's more than just the steepness in the hill. There's a formula, and we're going to give the simple version and then the more detailed version. So when we say slope, that is going to be the rise over the run. And what that means is the rise is how much that the slope goes up or down, vertical, over, so we could have another word for this would be vertical change, over the run, which is the horizontal change, how much we go left or right. Okay, so let's say on my first triangle over here, I have 50 feet on this hill, and I have 20 feet going up. And I want to write the slope. So for that example, it would be rise over the run, which would be 20, that's how much I went up, over 50. That's how much I went in this direction, to the right. And I can reduce that to 2/5. So for that particular slope, I would have a number value of 2/5 to represent it. Now, that is the simpler, more general definition. And as you move higher and higher in math, you get more details. So we actually have a formula for working out slope. And I want to show you what that is. Okay, so let's draw a graph here. I hope you have graph paper. And let's say I have this line here. And that goes through 2, 2, and 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. Okay? So it goes from here to here. All right, so if I wanted to find the slope of this line, what I would do, I'm going to change colors real quickly, is I would start from one point and I would go up to the height of my second point. See how this point here stops right there? So I would go up to that height there. And then I would go to the right to intersect with the second point. So I'm creating the triangle of the slope created by this line. Okay? So this side would be the rise, and this side would be the run. This would be the change going up, and this would be the change going to the right, or the horizontal change. Now, if I want specific numbers, what I would do is I would use my 2 points, and this is where our formula is going to come in. So this point would be my first point. This is point number 1. So I'm going to call this value x1, y1. So it's whatever those numbers are, x and y, referring to point number 1. So I have x1, y1 for point 1. And then up here, my second point, this is point 2. So my x and y values would be x2, y2 for point 2. So the numbers that are the sub-numbers are representing the points. They're not raised like a power. So you see we're having this is not the same as x squared. And it's all about where the 2 is. Do you see that? Or x1 is not the same as x to the first power, because it's all about the position of the number. Okay, so I have point 2 compared to point 1. Now here's my formula. Very often they use an m in math to refer to slope. And they just picked it, and always m refers to slope because it's very commonly used, and they want to designate that. So remember, we said the slope is the rise over the run, and that means vertical change over horizontal change. And what does that mean in terms of numbers? Well, I'm going to take y2, which is a vertical number, right here, this one, and I'm going to subtract y1, the other vertical number. And that's going to be over my horizontal change, which you can guess is right here, x2 minus x1 here. Okay, so that's my formula, and I'm going to use that to figure it out. So that is my detailed formula, and all you have to do if you have 2 points is substitute those numbers, and you'll come up with a slope. So let's try doing that. All right, number 2. Let's say we have a graph here. And I have this point right here. And it is at 1, 2. And the second point is at 5, 7. 1, 2, 3, 4, 5. And up 7. 1, 2, 3, 4, 5, 6, 7. Up there. So this point is at 1, 2, and this one is at 5, 7. And here's my line. Whoops, I missed. Try it again. 5, 7. Okay. And I'm going to use my numbers this time. Change colors again. Okay. So this represents x1, y1, and this point represents x2, y2. So my slope is going to be y2 minus y1 over x2 minus x1. Good idea to memorize that. All right. So in this case, the number that represents y2 is 7. Hope you can read that okay. And y1 is down here, which represents 2, over x2, which is 5, minus x1, which is 1. All right, so when I reduce that, subtract that, 7 minus 2 is 5, and 5 minus 1 is 4. So my slope for this line is represented by 5, 4. And it's positive. This is a positive slope. We don't see any negative sign there, and that is a positive slope. Also, we know it's positive because it starts down and goes up to the right. Okay, so here it starts down here and my line goes up to the right. Okay, let's do B. I'm going to go back to purple. Actually, let's make that number 3. Okay, so I have another graph. And this time my points are at 4, 3. 1, 2, 3, 4, and 3. So it's right there. And 2, 6. So I have 2, 1, 2, 3, 4, 5, 6. So there's my line. And this is my point. 4, 3, and 2, 6. If you want to pause it here so that you can catch up, that's fine, to graph that. So we can keep going. I'm going to change colors. All right, so I want to find my slope. And I'm going to go from, this is going to be, it doesn't matter which one is x1 and which one is y1. You just have to designate it. You will actually get the same answer if you reversed it, and so there's either way will give you the correct answer. It doesn't matter which point is 1 and which point is point number 2. So it doesn't matter which one is x1, y1 and which one is x2, y2. Okay, so we're going to find our slope, which is y2 minus y1, my vertical change over my horizontal change, whoops. And I have y2 here is 3 minus y1 up here is 6 over x2 is 4 and x1 is 2. Okay, so let's work that out. 3 minus 6 is negative 3 over 4 minus 2 is 2. So my slope is negative this time, negative 3 over 2. Now, it just so happens that the numerator is causing us to have a negative. Sometimes it's the denominator. It could be either one. At any rate, I only have one negative solution to my slope, either the numerator or the denominator, and so I have a total slope of being negative. Now what that means, this is a negative slope, and a negative slope will come down. So it starts high and comes down to the right. It comes down to the right. Okay? So that means up here, did you see how we started down and we went up to the right? That's positive. For negative slope, we start high and come down to the right, in a right direction. All right, I want you guys to try a couple OIOs on this. Use the formula to find slope. All right, and here's the 2 points. So I'm giving you the x1, y1, point 1 and point 2. And for number 2, I want you to find the slope for point 1 and point 2. Okay, so go ahead and pause the video now, and we'll come back in a couple minutes and compare your answers to mine. Okay, so here we're back, and I hope you figured these out. Let's check your work. I'm going to designate that as x1, y1, and that point x2, y2. So my slope is y2 minus y1 over x2 minus x1. You don't have to write that, but the more often you write it, the sooner you memorize it, and that's good for you. So y2, I always write it down. It just makes it so much better. y2 is 4, y1 is 1, x2 is 6, x1 is 2. So I get 4 minus 1 is 3, and 6 minus 2 is 4. So my slope for number 1 is 3/4. Okay, so let's do that again for the second one. Okay, so I have my slope, y2 minus y1 over x2 minus x1, and I have y2 is 0, that's okay, minus 6 over 10 minus 0. So I get negative 6, don't forget that, there's a minus there. 0 minus 6 is negative, and 10 minus 0 is 10. So my slope is negative 6 over 10. Now can I reduce that? Yes, I can reduce 6 and 10 by 2, so I get negative 3/5. So there are my 2 answers for the OIO. Okay, we have 2 more examples, and then we'll be done. Done, done, done. Okay, so this is going to be, let's see, that was number 3. This is number 4. 0 and undefined slope. You may or may not have seen this in Math 7. All right, so let's do A. I'm going to give you a picture, and we're going to look at it. I'm going to change colors here. 1, 2, 3. There's my line. Okay, and they give us 2 points, which are at 2, 3, and 6, 3. 1, 2, 3, 4, 5, 6. Okay, so what is the slope of a horizontal line? Well, let's find out. I've got my x1, y1, and my x2, y2, and I'm going to figure it out. Here's my formula again. And let's see what we get. y2 is 3, y1 is also 3, and x2 is 6, and x1 is 2. Okay, so let's simplify that, and I get 0 over 2. Okay, well, what is 0 over 2? 0 out of 2 is still 0. So that means that the slope of a horizontal line is 0. And that makes sense. Look at it. Here it is. Does that go up? Does it go up at all like this? No, there's no slope at all. Does it come down in this direction? No, there is no slant at all. So we know that for a horizontal line, the slope is 0. Okay, let's do B. I hope you catch up on that. If you need to pause it again, please feel free to do that. Okay, let's do B. Let's see what we have here for a line. I have a line coming down like this. And I've got -1, and here the point is 1, 2, 3, 4, 1, 4. Okay. I'm going to change colors again. All right, so here's my picture, and I want to find the slope. So I'm going to use my formula. I'm going to designate this is point 1 and this is point 2. Again, it doesn't matter which one is first or which, but I'm going to figure it out. So y2 minus y1 over x2 minus x1. Okay, so x2 is -1 minus 1. Excuse me, little allergies there. Okay, and x2 is 1 minus, oh wait, hang on, no, 4. This is 4. y1 is 4. Easy to make those mistakes. It's easy to get these confused. That's why I always write it down, because it's so easy to put the wrong number in. Don't do that to yourself. So I have 1 minus 1. Okay. Now be careful, I have a plus negative here, so I end up with -1 and -4 is -5, and 1 minus 0 is 0. Now this is a problem. The problem is I cannot have 0 in the denominator. How many times does 0 go into -5? We don't know, because 0 is nothing. You would think it would be nothing, but it's not. It's about how many times it goes into it. So it's undefined. Whenever we have 0 in the denominator, then our slope is undefined. So a vertical line has an undefined slope. Okay? So we can't define it, which there's something there. It's kind of like there's something there. It doesn't go slant down, it doesn't slant up, it's just neither one, so it's undefined. Okay, that's the end of our lesson for spring break for lesson 11.5. So I will be sending the homework home very soon, and I just want to say you guys are awesome. I miss you as your teacher. I hope you have a wonderful break, and we'll see you again April 13th. Happy Easter. Bye now.